Hey,
Okay,
good morning, fellow nerds, and welcome to another edition of Between Two Nerds. I'm Jeff Doyle, and with me, as always, is my friend and co host, Jeff Tansura. Good morning, Jeff.
good morning, Jeff. How have you been?
I've been great.
Life is
Hey,
great. Great to see everybody, and we are back in 2 weeks, as expected.
yeah. Is Microsoft treating you well?
Yes, absolutely.
Oh,
Cannot
cool.
expect anything better.
So everybody, you probably noticed that we've got a guest today, and Jeff, you want to do the honors and introduce?
Absolutely. Today with us is Kiyur Patel, longtime friend, longtime colleague, and one of the key people behind BGP in general. So even my dog, who bites particularly BGP coders, beaten him, so he's formally validated as the BGP person. Kiyor is going to talk to us about LSVR or link-state vector routing. So if you go back a bit, in 2016, in routing working group meeting, we had a discussion about what do we do in data centers. And as a result of the discussion, few proposals came up. Rift and LSVRs were two of them. So we've talked about Rift extensively with Tony P. LSVR got its own working group. Well, the specs are being developed actually in very advanced stages in their way to become RFCs. And Kiyur is going to guide us through what LSVR is, why do we need LSVR, and what's going on in routing data center in general. Kiyur, all yours.
Thank you. Before we get started, I just wanted to say good morning, gents. It's a pleasure to be here. Jeff, I've known you for such a long time, and Jeff Doyle. I hope I didn't massacre your last name, but I've been
Not
reading
at
your
all.
books, and it's been a pleasure to finally meet you and chat with you.
Oh, thank you. It's great to meet you too.
And great to see you both doing so well in these times of COVID. You're looking sharp, so it's always good to see healthy and strong.
They just locked me in this office down here. I haven't left here for like a year and a half.
Very nice. Very nice. All right. So, should we go down through the presentation track? How do we do this?
Yeah,
Absolutely. Please go.
yeah. Let's. There's the slides.
Super. So, I just wanted to give you a quick background and motivation as to why we started, then walk you through into the solutions, and then end it up with what we think is key benefits and takeaways for this, right? Technology. So, if you look at I'm just going to make sure the slides show up well. There we go.
Yes.
If you look at modern data centers, right, we have seen several things in modern data centers, and the key characteristics are that they're almost all of them as leaf spine fabric, some variant of leaf spine fabrics, right? 10 years back, they were layer two technologies. Fast forward now, about since 5 years for now, and I think for foreseeable time moving forward, they're all going to be layer three. Quite a lot of them have adapted to a very simplified version of control plane fabric. We see that is BGP. In fact, there was an RFC written as to how do you do routing in large scale data centers that was in your working group, Jeff, that talked about BGP as the fabric. The goals when most of these operators used BGP was scale, simplicity, and very resilient architecture from control plane standpoint, which naturally translates into a data plane forwarding. So what's next for these data centers and the new data centers that are coming in? You're going to see growing ECMP scale as more and more towers get deployed, server racks get deployed, it becomes fat and it spreads, and you're going to see ECMP scales grow, or the pods get replicated and the pod scale, um, which effectively results into an increase class tiers in a lot of big data centers, and you're going to see more and more applications move into data centers. No brainer there, right? As we start looking into that, and as we use BGP as a fabric, how does that translate into? So if you look at BGP that's been deployed in data center, it's typically again a leaf spine. It's multi-tier. BGP is hop by hop. Now here, comes an interesting challenge. If you look at 5 years back, the spines, let's take a flavor of a spine, right? If you looked at a Broadcom version, the spine typically is a tomahawk-like switch. And you look at Tomahawk's first generation chipsets, they came out with 32 ports of 100 gigs. That was what, 3 point something terabits. And then typically in data centers, the leap in terms of scale is about 4x. And you saw a lot of data centers deploy TH3 now, which is 128 ports of 100 gigs. What resulted into is that the port densities at the spine became more packed, and you see more port densities. This naturally translates into, if you have a hop by hop peering, into more BGP sessions as the fan out grows, because BGP sessions are per peering. And that puts a scale factor in terms of BGP peering as you start to look into it, right? And this has a direct correlation with your ECMPs because you deploy it in a hop by hop fashion. So if that 128 in future becomes 512, then you see the BGP peering exploding to that many peers. Of course, when you do this, the link layer liveness and everything has been taken care of by likes of BFD or some layer 2 protocols. So we're not worried about link layer liveness, but you're only focused on the fan out. And then in BGP with that fan out, how do you do fast routing at sub-second convergence or as close to that as possible, right? As we look into that problem particularly, you start to look into it and you say, well, let's start looking at IGPs and let's start looking into BGPs and let's do some kind of a comparison here. And if you look at the strengths of IGP, you see it's a complete fabric topology that has been provided by the virtue of fact that you run Dijkstra. Since you run Dijkstra, you have full information, you build the graph out of it, and you do all sorts of things, including run SPF to build the graph or do path computation, so forth and so on. Claims to have and does have actually a very fast convergence. Although scale is limited in that case. The perceived downside here is flooding techniques that are used in IGP and the complexities that you use to build a IGP state machine, effectively a graph that you're looking to build after. If you compare that to BGP, it's very simple. Operational troubleshooting is very, very well known. So cost to deploy BGP in data centers or in SP world is somewhat minimal in sense that all operational aspects, including troubleshooting, is very well known. Has inherently inbuilt superior mechanisms like, hey, I can run it on reliable channel, TCP. I can do incremental updates. I don't need to do flooding. I can do selective filtering. I can do per hop TE unequal cost multipath if you want. Convergence is pretty okay. It's not as fast and good as IGPs, but it has massive scale at which it gives you a convergence. So it's a different comparison in that regards. And while we are at it, the configuration can scale out itself and become a nightmare in its own self, right? If you look at IGPs, again, like I said, they give you a faster convergence. They give you a lot better in that regards, and their configurations are very simple. So when we started looking at LSVR, we said, hey, if we have to look at the next generation fabrics, how do we build that fabric in a way we take all the complexities out of BGP, the perceived complexities or the known complexities, and then complement it with the better parts of IGP that you see, which is fast convergence and a complete topology view, which is Dijkstra effectively. And how do you carry that information to facilitate the Dijkstra? So that's what we did. And we kept the simple aspects of BGP intact, which is, hey, it has reliable transport, so don't mess with that. The reliable transport actually allows you to do incremental updates, thereby eliminate all kinds of flooding, and it's a superior version of it. And it can also let you do selective filtering in case you want to in certain parts, right? Though in data centers for the fabrics that you're looking for, particularly underlay, you actually don't need a lot of filtering in there because the scale is not that much in it. And there isn't much about policy based filtering to do other than a CSPF like functionality that you look in IGPs. So if you fuse these two things together, then that essentially becomes link state vector routing. I'll pause here for Jeff and Jeff to see if you have any questions so far.
Yeah,
Yeah,
I'm
I'm
curious.
curious.
Oh, we've got
Oh,
an
we got
echo
an
in here
echo in here
somewhere,
somewhere, but
the in this case, does the BRIB, the BGP rib, take the place of a link state database for the sake of SPF calculations?
Pretty much along those lines. So you have an in-rib that is intact, that you want to hold BGP updates in whatever form and implementation can, and then the B-rib is pretty much a natural outcome of your SPF execution, and suddenly it becomes a final result of your SPF that you then push it into the rib, right?
Okay, gotcha.
To bring it in context of the previous podcast with Tony Lee, so what Tony was trying to do is to reduce amount of flooding by decoupling flooding topology from physical topology. So you still flood, just less, because you don't flood to everybody, you flood only on particular channel. Here you're using BGP technology to reduce amount of flooding because BGP only incrementally floods. So it's different way to address the well-known flooding storm problem.
Okay.
Yeah. So naturally, what it gets into is a topology that allows you to now have a very reduced flooding. And we'll talk about how you get to a complete elimination of the flooding also, right? This has been already done and deployed inside BGP. You folks know it very well. I'm simply going to draw your attention to it. But effectively, now you can build a IP class architecture that has multiple peers. You can have route controllers in it. The configuration complexity is completely eliminated. Why? Because you don't need to have hop by hop peering. Instead, if you just pair with a notion of route reflectors that we have in IBGP world, in SP world, if you have some similar notion that you do route reflectors for eBGP, and we call that as route controllers. If you simply pair with route controllers and have each one of these leaf spine elements send their own direct connectivity information out to the controllers who can then send it on a channel to all these uh, points in the network, point to point, kind of like a route reflector and route reflector clients, then your configuration complexity is now reduced to one peer configuration, which is essentially what we did with route reflectors when we wanted to eliminate full mesh within a given cluster. Yeah. So completely eliminates the configuration, simplifies it. You have route reflectors deployed at the scale. The job of the route reflector here or route controller here is even more simplified than route reflector. If you notice route reflector, it receives the routes from each one of these clients, runs the best path, and then announce the best path to rest of the clients. In here, you don't even have to run the best path because the route reflector may or may not be in forwarding path. If it is in forwarding path, which means if one of these boxes are route controllers, then yeah, you run it. But if it's a route controller that is purely a virtual, you don't need to run best path. You simply reflect it and you're done. So it's a purely controller that gives directly connected information of each of these nodes to each one of these nodes. And then when you replace distance vector algorithm with Dijkstra, you build that underlay graph that IGPs do it with. So you can see how you can completely eliminate the flooding aspects, which we do in BGP, assist with reliable incremental updates transfer only for your interfaces that are directly connected on the box, not for any other, because this is an underlay SAFI, and that's it. And when you announce it to everyone else, they can do distributed computing, run their own Dijkstra, because all of the switches come with high powered CPUs. And if you just reduce them to do what they are best for, now you've got a distributed computing algorithm in place using BGP, which is well known. We know that operationally there is minimal cost to deploy BGP because it's very well known from troubleshooting, understanding, protocol heuristics, all these things. You've got a simplified fabric now, which builds an underlay. So that was essentially the motivation for doing LSVR. Let me pause there and see Jeff, if you have any questions before I go into solution details.
None for me. This is pretty straightforward so far.
Yep.
And as you go and provide more details, how best paths have changed, I assume it's going to become much more clear what exactly the difference between regular BGP versus LSVR.
Correct. So from a deployment perspective, you can have flexible models here, right? The left side centralized path computation is you have a virtual device running that actually pushes not just the topology, that not only gets the topology view, but also pushes the path computation. So you actually can run Dijkstra just at here for all this n number of devices n times and then push the result down. This is what they do in the centralized model. You can do very well with this, right? This is one flavor of it. Then the second flavor is that you could do distributed path computation, meaning you use the controllers and the path computation is now simply pushed down to every level that we were talking about. And simply this tier is acting as a reflector, or you could have a virtual device sit here and peer with all of these guys, and it could do the same thing as a reflector, kind of like this model. And then the third model is that you also bring in the topology, which is sitting on a virtual device in band here. Typically, the spines have a lot of CPU power. So you simply bring them out here. You have 3 or 4 or n-way spines that you have configured. And now from here, you can stream out your topology information, but the route controller simply reflects the routes from here, and everybody does the distributed Dijkstra. So you have a flexible deployment model. In all cases, you can see your configuration is reduced drastically depending on which model you pick, and it becomes more simple. In case where you need configurations, it becomes absolutely a cookie cutter. So your margin of error in the configuration aspect reduces drastically. In fact, you can completely auto-configure these things, right? In all these cases, again, your link level detection is done by things like PFD. So if you conceptually look at it, the data center switch fabric has overly been simplified using things like LLDP that can discover the links, BFD that does link level liveness, and then you have one protocol that simply runs BGP overly simplified, and off you go. You build underlay fabrics, and on top of that, you can have an overlay protocols like other BGP SAFIs that can recurse over it. The big benefit that we think with the customers would be you have one software stack, very simplified, less number of features, nimble software stack that has a much better sell value, if you will, to the customers and operators, particularly in data centers, because they can say, hey, we know there is nothing else other than few software elements, and the switch software has become overly simplified in terms of management, both from an engineering standpoint as well as from operations standpoint. Yeah. How did we do it? We came up with new SAFI to say, hey, let's take this in parallel, right? A new SAFI is always cleaner for something like this. So we came up with new SAFI. Typically, when we do that, we have to define a new message, less of a message format, but more of a prefix format and attribute formats. Now, if you look at IPv4 and IPv6 address families inside BGP, they carry prefixes and attributes. They are more suitable for those message formats are more suitable for algorithms like distance vector or a path vector algorithms that traditionally BGP is built with. But when you start to do Dijkstra-like operations from an algorithmic standpoint, why when you compute the best paths, your message formats have to be a little more friendlier so that the encoding decoding becomes a lot more easier. And for that reason, we have chosen a message format of LS-SAFI, which takes actually an IGP information and streams it out. Today, it only streams it out for telemetry purposes, but it's perfect to run Dijkstra on. So we took the message format of LS, replicated it in here, and then what we did is that at a very high level, the solution over and above in a need of a new SAFI LS-like message format needs to zap the phase one, phase two, and phase three of decision process that was defined in RFC 4271, which is BGP RFC, and replaced it with Dijkstra as an algorithm, shortest path. So you take LS information, which is very friendly to Dijkstra, feed it to Dijkstra as part of this new SAFI, get the SPF running executed, build a table, install it into the IPRAB, and suddenly you have IPv4, IPv6, SPF like graph like underlay routing at place over a reliable SAFI. It is pretty much, if I have to say, if you take ISIS, and this is one of the case studies we had done, in fact, I had done with my co-author AC Lindum at Cisco. If we had to replace ISIS and bring it more like BGP on a reliable transport, you would have seen this enhancements in BGP would bring you closer to ISIS with that reliable transport. Although I would probably challenge is that the code changes here required are fairly minimal.
To add a bit on BGPLS, it's not an entirely new technology. People have been operating BGPLS for at least 5 years. If you look to any hybrid deployment that runs distributed routing with centralized computation, northbound protocol is BGPLS. You would use BGPLS to collect all the data that might also include segment routing seeds, that might include RCPT information. By the way, we just published RFC 2 weeks ago on that, and feed all this information into centralized controller that might apply constraint SPF or any other business logic to compute path. So this technology is very well known and very solid.
And you could think about that over and above what Jeff said. This is actually, if you're going to overly simplify it, is LS with Dijkstra enabled, and it just pushes it into the new SAFI so that you keep the telemetry as well as fastening fabric SAFI is very different. And you could draw that parallel if you like. This is something that I say. Now, when you start going down that path, few things become very interesting. Is to say, well, how do you essentially make sure that BGP always guarantees, by the way, that we announce most recent versions of the route changes? But how do you absolutely nip it and nail it down to the wire? And one of the things we did was introduce the sequence numbers. The concept is very well known in IGP. So if you just replicate that out here, then you are pretty well to go. You could do loop detections very easily and drop the duplicate updates that are going back and forth as well. Now, there's no constraints, but we started off with a very simplified version of SPF with point-to-point links, which is the characteristics of data centers, and that's where we started. Scales very well. You could support LFA computation of all sorts, and like Jeff said, segment routing SIDs and other features, right? Day one supports V4 and V6. BGPLS already has a formats for VPNs. We haven't enabled it because we don't see a need in the underlay SAFI for that. And we were only focusing this solution to be for an underlay SAFI, right? Then the obvious question is, hey, if I have enabled IPv4, and I do LSVR for IPv4 fabric, whose routes should I prefer between two address families? Well, the clear answer is you don't do that. But from a routing perspective, should you do a crazy stuff like that, then we need to figure out a way. In the last RFC change, I think we have come around and said as a suggestion that by default you should give the SAFI a higher preference value. And
And operationally, it's always good consideration. If you remember, we always had this software with labeled and unlabeled artists in BGP. So whether you preferred label route as per 3701 or unlabeled route, and many implementation had really bad conditions here. So it's always good to predictably configure one API to take preference rather than having conditions where there's competition between two different APIs to produce best route.
yes, absolutely, absolutely, completely agree. So the latest draft copy does reflect this and says, as a suggestion, you can always override it, right? That brings us to route origination. Well, if the SAFI is operational and up and running, how are you going to populate routes in this? Remember, I said that you each switch, or be it a spine or a leaf, should only announce his originating data and then only forward other information received from other peers or BGP neighbors to everybody else, right? But should not originate any other data. So there are two cases where the routes need to be originate. First is if your local interfaces and routes related to your local interfaces or static routes that you have configured on the box, they should be originated. If you're a Tor, quite a lot of times you will learn layer 2 information behind layer 3 information behind you, and it's quite possible that you want to be represented for that information such that reachability is built in. Either you send a summarized route or you send more specific routes. So one of the two cases that you need to handle, and then the fabric is pretty much built on its own. The first case I talked about is purely a matter of redistribution. So routes originated by redistribution, static or connected. And then we also came up in LSVR working group with this new discovery protocol that we are working on. And I'll take a minute and explain that. Is to say, today you have ARP, and ARP is the only way to discover it. But imagine if you had a layer 3 discovery protocol that would say, hey, this is my IP address, this is my SID binding, and this is my MAC address. And by the way, these are my overlay addresses, and these are the set of VMs that I'm running on. Just something as plain as discovery protocols on a reliable channel, kind of like how BGP is or BFT is. In this case, BFT would be far more interesting case. And if the channel goes down, or if the channel stays up and your MAC move happens, and therefore your layer 3 subnet moves or layer 3 address moves, and you simply withdraw that route, it becomes a much faster fabric overall and very easy to detect it. There are no guesses from an operational perspective to say, why did that server withdrew that layer 3 address at 11:45 a.m. today? Oh, well, I have no idea. Now it's very clear that A, the server has withdrawn that route. B, that route was withdrawn because the RIB or this protocol that was running there has figured it out. And now I have to focus my attention on debugging that server, not the entire network, and then get to the server. So if you have a layer 3 discovery protocol like that, becomes extremely easy. And the intention is not to replace the ARP, intention is to augment layer 2 like information with 3N. And that's another way to know server addresses that I was talking about, that you can inject it into LSVR. Or you could do it with the mechanism that is there today. You learn a MAC route or a MAC address, and you learn the IP bindings, and you just announce it out as an underlay reachability, not the overlay reachability. But The LSVR group is targeting such that the discovery can distinguish underlay versus overlay. Therefore, you know which SAFI unit to send appropriate bindings into and get it working, right? So that's what we have done. There are some convergence improvements that we have put in sense that typically if you see a link is going down and you see the neighbor goes down, well, how do you announce it to the rest of the BGP neighbors in the clause very quickly? So we withdraw the link. The LS format does allow you to announce link reachabilities as well as address reachability in a different TLVs. So we simply withdraw that, and it's very analogous to fast session deactivate kind of a thing that you just pull it out, and then the SPF on the neighbor's side would very quickly figure out the link has gone down, and they would converge around that, kind of like how we do TILFA today.
Hey, Kier, sorry to interrupt. I think we've got a question from one of the viewers here.
Yes, absolutely.
And I should have said earlier, if you have questions, please do post them. But let's see if our producers will pop up that question. There it is. So can we have prioritization by using the CLI?
I am assuming he's talking in context of the route prioritization, and absolutely, if that is the case, you today can override route preferences anyways with different protocols across different protocols on the router platform. So absolutely, you can have that. The default suggested was you give preference to LSVR, but you can completely override it. Yeah.
There's another interesting use case, probably that hasn't been discussed before. We've tried to deploy MPLS end-to-end in some data centers. I mean, by we, I mean industry. And it always has been a problem to learn label to IP binding from the host or server that would do MPLS. So in ATF, we try to do it through labeled ARP, which would do it, but as we know, ARP is only used for IPv4, so it wouldn't work for IPv6. And so some part of ATF disliked before solutions on there, right? So you need to do the same for ND, which has very different format, and you redo the work. Here you've got unified protocol that can tell you, I'm a host, was running before with 6, and by the way, this is the label you could use to send traffic to me. So it simplifies and unifies label discovery on the host.
Totally. Very well said. And then I was going to very quickly go down to say, hey, there are other cases where you can go around and say, you can also do the same thing that you do with the link withdrawals, with the NLRI withdrawals also, if there's a specific prefix you want to withdraw. Again, in this particular solution, you're assuming link liveness will always be done by BFD. So the link withdrawal could be done by BGP, but the liveness detection is always done by BFD, right? So if you look at switch software, the key benefits and takeaways are it builds on top of existing protocol. You don't need to know that protocol. It's very well known. I'll reiterate. Operator community knows exactly how to debug it and manage it in the operations. And of course, we know how to build features on top of it. It enables faster scale and convergence, where you see bottlenecks have been perceived bottlenecks or configuration complexities have been eliminated, which also allows you to deploy centralized architecture as well as do efficient traffic engineering. So you've taken the best of the both worlds fused together and built a good underlay protocol, which now is also a BGP, far more efficient than IPv4 unicast hop by hop. And when you combine that with a EVPN on top of something like this, it enables full programmability that you are after, like I said. And last but not the least, when you bring into this puzzle things like L3DL, what it helps you do is complete automation, end-to-end, complete monitoring, And as you go after end-to-end traffic engineering, this becomes pretty sleek solution that you are after. So this is what we started off with. Of course, we have an implementation. If any of our viewers are interested in doing some performance analysis or wanting to do some comparative analysis, happy to talk about that as well. Yeah. I'll pause here and see if you guys have any questions.
Yeah, I mean,
So
you
very clear,
anticipated
very
the first question I had, which was how do we get our hands on this to play around with it? Is this particularly an Arcus implementation at this point, or is there something in terms of freeware, that I could get my hands on and put into my lab behind me here?
Yeah, so there is a version of LSVR that was implemented on Quagga FRR. So you're more than welcome to take a look at that. That was done. Now that implementation definitely has route controller like support for sure, that I know because we interrupt with it. Much loaded and a complete solution with almost all features are of course based on the Arcus solution. But nonetheless, the FRR solution should be a pretty good, interesting start. Yeah.
So, and similarly to Rift and flood reduction, this work is done in ATF. Specs are open. Anyone interested could take spec, at least to read it, to understand, or to go and implement it. So it's a completely open solution from this perspective. We, as ATF, are trying to bring innovation by making it open and then letting people to build on top and bring their own IP.
And so you should be able to go to the IETF website, the data tracker, and search for, I assume, LSVR and find the relevant internet drafts, right?
Yeah, so LSVR is a working group. It has number of working documents. So LSVR base spec is one of them. There are some additional drafts that talk about applicability, auto discovery, and some other stuff. So if you are interested, there's definitely enough information to read for better understanding.
Cool. Any other questions from our audience? Anyone tuned in that has some questions for Kier? All right. A lot of silence out there. So, Jeff, any additional comments from you?
Yeah, Kier, so how can people follow you, reach out to you? What's the best way? Where are you active?
My email address is always online on the proposal that we have written. But in any case, you can reach me at keyur, KEYUR, at arcus.com, ARRCUS.com.
And at this point, do you have customers running this?
Yes.
Is everybody still experimenting with it? You have
Yes.
live customers?
We have
Cool.
a few customers who have been toying and playing around with this in a very serious manner. They are typically a cloud customers, I would say, cloud data centers who are looking at it very closely and running at it. Some early performance analysis has been done, and it has stood up very well against the likes of other SPF based protocols. So it poses a very good alternative, particularly if you are a flavor of a customer who has a mindset of running BGP in data centers.
Great. And I think we do have another question from a viewer. There we go. Is there an Arcus virtual machine to test with?
Yes, we do. And we'd be happy to provide you with one to play around with. If you just shoot me an email, happy to do that.
Great. Well, cool. I think I've asked all the questions that I've got. I'm looking forward to playing around with it and building my own knowledge here.
And the last thing I'd like to tell my all our audience is that look, it's a pleasure to talk to you, Jeff Tansura, and the way I worked in past, Jeff. Doyle, is that even though when we worked in different companies, I would code up things and build products. I would take all claim to fame for the product that has been done. And for all bugs, I would always accuse Jeff of putting those in, which will be the case here as well. All the bugs and blames will go to Jeff Tansura
That's,
as my close friend.
I think we should just extend that to any bugs on the internet. We'll just blame them all.
That is true. That is very true.
You could use Twitter to express your unhappiness.
But in all fairness, Jeff D, he keeps me very honest when we're building solutions. So it is always a pleasure to work with him and now with you as well.
Well, it's been a pleasure having you today.
Super.
Thanks for being with us, Kiyur, and we are looking forward to further interactions. Definitely not the last meeting we are having together. So we are looking forward to you becoming friend of the show.
Thank
Yeah,
you.
we definitely want to have you back. This has been very interesting, and I think as the audience processes all of this a little bit, there's going to be a lot more questions, and we will certainly be wanting to have you back on.
Absolutely, it would be a pleasure.
Well, thank you so much, and I want to remind everybody in the audience, as usual, if you like the show, please like us on Facebook. On Facebook, I always say Facebook, on YouTube, and be sure to subscribe to our channel on YouTube. And Jeff, it was great to see you again. We're a little more distanced than we were for most of the show, so I seem to have the pleasure of seeing you primarily on this show these days, but we're going to have to link up a little more closely.
Absolutely.
Okay, well, thank
Great
you
to see everybody.
for watching, and we will see you in 2 weeks.
Take care. Stay safe.
Thank you.